My name is Joel. I work in the LangTools group here at Oracle, doing annotations, annotation processing, work on Javac, and also related language work. I used to come from the JRocket engineering. I used to do hacking on the JRocket Java virtual machine previously, and then I joined LangTools a year ago. So I'm here to talk about annotations, annotation processing, and what's new in JDK 8. And this is going to be a little bit of an overview talk, because we have three major features that we are doing, and they are mostly related, at least on the surface, by being annotations features. So I'm going to sort of go through all three of them. And here's the standard Oracle disclaimer. Don't make business decisions based on this. And in this case, I also want to add, actually, that this is stuff we are currently working on. So this is a snapshot view of what we have today. It will probably change, hopefully for the better. So this isn't finished yet. So I'm going to start with JSR 308 type annotations. And this is something, there was a talk about this yesterday that you might have seen. So I'm going to keep this a little bit short. So today we have annotations on declarations. You have declarations introduce a new name into your program. So here are some example declarations. Very simple: a class and a type parameter, or type parameter. And in the last example, I actually introduced three new names: a method named v, a parameter named I, and the long named L. And all of those you can annotate today. But with 308, we also bring you the possibility to annotate type uses. And this is something you haven't been able to do today, until today. And I've included some example of type uses. For example, a constructor call. You see the my object, that's a type use. I'm not declaring the type my object, I'm using the type my object in a constructor call. And also, for example, in a cast. You couldn't, previously you couldn't annotate a cast, now you're going to be able to. And this is also a type use of string, not a type declaration of string. And in implements clauses, a read-only list of read-only elements. In exception, in thrown exception declarations, for example, a critical temperature exception. So these are all new places that you will be able to add annotations to your source with 308. And you might ask, why do I want to do that? And it turns out that the annotations themselves in this case aren't the really cool thing with 308, but the checkers are. So the annotations in those places are an enabler for the checkers framework. And the checkers framework is a way to write your own type system on top of Java's type system. This type system it's based on a plugin that you write. So when you run Javac with your plugin, you can type check your program with the properties, for the properties that you are interested in. So you write the checker that you want, that you need to be able to prove the property that you're interested in. And in order to prove those properties, it turns out that sometimes you need to annotate the code. And that's the basic reason we're adding these type use annotations, because they're needed in order to prove interesting properties about your program. It turns out that on average, the checkers framework guys, they had to add 2.6 annotations per 1,000 lines of code. So they don't need to add too many type annotations. You can find more information about the checkers framework here. It also includes a bunch of those pluggable type checkers. I've included here 3 of them, or mentioned 3 of them. There's a nullness checker that can prove the absence of null pointer exceptions. And I think we can all agree that's pretty useful. There's a lock checker that proves that if you have a variable that's supposed to be guarded by a lock, it can prove that you only access that variable while holding the lock. So it proves the absence of one type of concurrency issues. That is pretty far from saying that your program is free of concurrency issues, but this is a small step. And also there's the regex type system that can prove that a regular expression is well formed, and also that you don't use capture groups that you haven't introduced. So this will give you the property to verify the absence of a class of common errors that you could otherwise have. So, right. And we're also doing this. To me, this looks like a little bit like Python, except in Python it would be named self instead of this. And it turns out that in a virtual call, when you're sending a message to an object or invoking a method on an object, that object itself is sort of always present in that method. And sometimes you need to annotate the receiver of that virtual call. And we couldn't figure out where to sort of actually do that. So we allow you to have an extra parameter named this that you can annotate with type annotations for the receiver of virtual calls. Hopefully this won't be that common, because it's sort of I think it looks a little bit weird, but if you need it, you need it, and then we have to be able to do that. Right, and yes, this slide. So I added some random annotations to a lot of type uses here, and with this I want to say that there may be a cost to overusing type annotations. The annotations are starting to distract me from the logic of the program. But I mean, so we are giving you the ability to shoot yourself in the foot with the syntax here. It's up to you to use it with moderately. And of course, type annotations, you're free to use them without using the checkers framework. You can, if you have the need to annotate type use, then just go ahead. This isn't tied to the checkers framework. So, type annotation summary. We want to extend the type system of Java, give you the ability to write pluggable type checkers, and sometimes the type checkers need a little bit of help, and in order to do that, we add the type annotations. And of course, they're there to use even though you're not using the checkers. And that leads me to repeating annotations. So this is the second feature that we're introducing in Java 8. And I've been working on this. Type annotations has been done outside of Oracle. And I think that's a great thing as well. It proves that it's the perfect example of being able to do work in the open outside of Oracle and bring it to us and say, hey, this is cool, we want to do this, and then do it. Repeating annotations, I've been working on that. I've been doing the changes in the Javac compiler. So, and this comes, the repeating annotations comes, the need comes from the fact that today you can only have one instance of an annotation of a certain type per declaration. So you can't write at foo. We think that was a mistake, and it has turned out to be, there is a need to write multiple instances of the same annotation type. For example, I think you might have seen this. In the EU world, I think it's quite common that you have to wrap the annotations that you want to have multiple times inside a container like this. Here's another example. Schedules in, I think this is, no, I don't remember where I got this example from, but you want to trigger your action at multiple times, so you have to wrap your multiple schedules inside a schedule container. So we prefer if you could write it like this. I think this is much neater. And the schedules example would look like this. I think it's much more readable. So the repeating annotations feature helps you to write more concise code. We want to help you to get rid of the sort of the boilerplate code. So, given that you want to use this, how do you do? So, you take your annotation type that you want to use, in this case, the schedule, and you annotate the schedule declaration with a contain by annotation. And the value of that annotation is a class, in this case schedules, that is the container for your multiple instances of schedule. So you take your schedule and you write a contain by annotation saying, here's my container. And you can name it whatever you want, but in this case, it's named schedules. And on the schedules side, you annotate your container with an annotation called container4, saying, I am the container for this annotation. And also, it needs to have a value element that is an array of the annotation it is a container for. So in this case, it needs to have the value, the array valued schedule value. And there are also there are rules for example how if you if your schedule is documented, the container needs to be documented, and there are targeting rules. But this is the basics. So if you do that, Javac will transform this source code into sort of a bytecode representation that looks like the example below. So we will take your two schedules, we will pack them in the container for you, and we will include the container in the bytecode. And the reason we do it this way is that there is, as I showed you, there are a lot of examples of where you already have this idiom of using a container. So we want to sort of we want to make it easier to continue to use that with less boilerplate. But we recognize the fact that this is already used in a certain way, and we want to continue to sort of build on that. So we synthesize a container and we pack the two or more annotations there. Yep.
Is contained by repeatable?
No, contained by is not repeatable, and neither is container4. So I can actually And there's also the requirement of there's an exact type here. So you can only be the schedules, the array valued value element that needs to point exactly to the type of schedule. So you can only be container for one annotation. Right. And we also need to add some reflection support, it turns out. And first I thought, well, this should be rather easy. We have an existing idiom. This shouldn't be a big deal. And so this leads to sort of my rules for evaluating language changes. So there are a lot of proposed features to Java. We are not going to do all of them, but we have to have some sort of criteria. How do we choose? And personally, these are sort of my rules for evaluating how I feel about a language change. So, for example, if you don't use a proposed feature, you shouldn't suffer at all. And I think this is pretty reasonable. I mean, you're sitting, you have your code here, you're writing, you don't use the feature, and suddenly someone introduces something over here, and you start to suffer. That is sort of, I really dislike that idea. My other sort of criteria is that the users of the feature should find it intuitive and easy to understand. And my colleagues always say that backward compatibility is important too, and I agree with them. So in adding reflection for this feature, these are sort of the criteria we worked with, I've worked with trying to figure out how to best do this. Because it turns out that if we don't change reflection at all, adding one more schedule to your schedule or to your action, if you look at the annotations in reflection, you would lose them. And to that, Duke says, "What? This is not the way we want to do things." And the explanation is this. So I'm going from one schedule to two schedules, and the compiler is going to. So and that means that on the class action, previously there was an array of annotations, and that contained one instance of a schedule annotation. And now that array of annotations on the class is going to contain one instance of a schedules annotation. So that is why we lose the schedule when we are looking for schedules. Or when we are looking for a schedule, we lose it because there is a schedules there. So we need to unpack the containers. And the spec says basically if an annotation A that you are looking for by doing the annotated element get annotation or get declared annotation, if you're looking for A and A is meta annotated with contained by, then if you can't find it directly, go and look for A's container. If A's container is there, unpack it and take the first one. So, and that will give you, given the declaration, you have two schedules on action and you look for a schedule, you get the first one. And, well, we think this is pretty reasonable. But it turns out we're not done yet. So it's the same example. You have a schedule, you add the second schedule, and this time you're doing the call get annotations. And it turns out here you lose your schedule as well. Before you will get an array of that had a schedule instance. In this case, you get an array that has a container instance. So again, Duke says, "What? So it turns out that we want to unpack containers when you do the get annotations call as well. So, what did I mean by that? Yeah, so given the declaration there, doing get annotations on action.class should give you the array of schedules. And as it's actually a container there, we find the if the instance of a schedule of a container is annotated with container 4. This is a bit tricky. So when we find something in that array, if it is a container, which it is if it's annotated with container 4, then we unpack it for you and add all the individual annotations from the container to the return value of get annotations. So in this case, you will get your 2 schedules on the get annotations call. So here are the proposed updates to annotated element. And as you can see, there are 3 new methods. There is the one on the top right that we felt that was it was missing. It should have been there from the beginning, basically. Why can't you do get declared annotation for a single type of annotation? Why do you have to do it with inheritance, taking inheritance into account? So that is added for completeness. And the other 2, the middle line, those are added because they are interesting when you have repeating annotations. And those are the ones that we think you should be using when looking at annotations, because this takes repeating annotations into consideration and will give you. Let me get to the next slide. So the two ones in the middle, they are the repeating annotation counterpart to the old get annotation with a class parameter. So they will give you all annotations of the instance of the type you're looking for. So you get an array of multiple annotations back. All right. This is the intended semantics of the get annotations looking for a type. So if your class action is annotated with a single schedule, you get an array containing a single schedule. And if it's annotated with multiple schedules, you get an array containing multiple schedules. All right. So that was the repeating annotation part. So we think it was a mistake to just allow one instance of an annotation on a declaration. We want to fix that. We have decided to fix it taking compatibility with the existing idiom into consideration. So we transform your repeating annotations into this container. So we synthesize a container for you. So we put them in a container. And then we've updated reflection to, where it makes sense, unpack the container and give you back your original annotations. So my idea of how to do this has always been that, and even though this isn't the case today in all cases, but if you have annotations in your source file, I think it is reasonable to try to give them back to you when you do reflection as well. So that is sort of the underlying principle here. And for example, since class retention is the default, for example, it isn't always the case that you have that today. But I still think it's a good, a reasonable goal to have in mind. All right. That leads me to the next part. Javax.lang.model backed by core reflection. That is a long title. And here again, I want to make the point that this is work in progress. This is I have this running on my computer. I'm not going to demo it because I tried to do a demo yesterday, and it turned out it required network access, and it all sort of went boom. And while I strongly believe that Javac doesn't require network access, I am not 100% sure. So I've included the demo in the slides. But so this is something we are working on. We want to give you this. We don't know when, and we're not sure exactly how it's going to look either. But I'm going to give you a snapshot view. So how many of you have used javax.lang.model in the source world? 5. And one of them is the original implementer of the API. All right. I have a short introduction to the javax.lang.model API. Perhaps I should try to make it a little bit longer. But so I'm going to start by saying that this API today lives, or before this work, this API lives in the source world. This API runs as a part, or you are using this API today with annotation processing. And that is done at source time. So this API sort of lives in the Javac compiler, and you are using it when you compile your source, not when you run your program. And this effort is basically we want to take this API to the runtime world, or to runtime time, or program execution time, instead of compile time. So that is basically what we are trying to do. Javax.lang.model, or maybe I should just say the model API. It's an API to talk about Java source, and it's unlike, for example, reflection, that also sort of talks about your program, but is a sort of a hybrid source bytecode view. Reflection is very much based on the how the code looks for the VM, while the javax.lang.model looks at the source. And also, this API is, let's say, at a higher abstraction level than reflection. For example, visitors are included. You don't need to do iteration yourself. This is, for example. And most users today, I would guess that most users of this API today are using it for annotation processing. So when you do annotation processing, this is the API. If you're not using APT, and you shouldn't be using APT, so if you are using the JSR 269 annotation processing tools, this is sort of your way to talk about the source when you are doing annotation processing. So, included in this API is a nice set of visitors to extend. For example, there's what's called an element scanner that will just iterate over all your elements in a source code, and you override a method for the visit. You override the visitor that you're interested in, for example, visit method, and it will do the rest. There are a bunch of utilities to reason about or query about source code and types. For example, overriding, which turns out to be surprisingly tricky at runtime. If you're not a VM, for the VM it's quite simple. But if you're looking at bytecode, trying to figure out if something overrides something is actually quite hard. And you can query about hiding, for example. And there's also utilities for the sort of the type part, where you have you can ask and query about bounds and wildcards and subtyping and all that. So this is a much more complete API to talk about Java source code and to a certain extent Java semantics. So for example, yes, this is I think this is my favorite example. Overrides. So given the three class interface declarations, you have class A with the method M, you have interface B also with the method M, and you have class C that extends A and implements B, but doesn't declare any methods. Does A.M override B.M? So, and this turns out to depend on which perspective you have, because A.M will be the method executed when you call C.M as well. So if you take on your I'm class A hat, then A.M does not override B.M, or in this case, since it's an interface, does not implement B.M. But if you look at the same declared method in the source code of A, but instead look at it from the perspective of being a C, which inherits the method M, then that M will actually override B.M. And this is one reason why this is so tricky, and this is a horror to figure out using reflection today. I've done it, trust me. But this is one of the things that is really easy to do with javax.lang.model API. Right. So the model API consists of a bunch of packages. You have javax.lang.model element.element. This is sort of the base. This is the base class for elements in the source code. For example, you have a type element, and that would be that corresponds to a class. You can have a package element that corresponds to a package. You have method element, or it's called executable element. And then you have sort of, and this corresponds directly to source code. For class string, you have exactly one element string. And then you have what's called the type view of it. And this becomes a little bit tricky. But this, you can mostly view it as sort of what you need to do to talk about generics. So for example, there is only one string, there's only one type element for string. Well, forget that. So take list, for example. You have list of E in the JDK. So there's one type element for list, but there are many instances of type mirrors. For example, a list of string is a type mirror, and a list of integers is another type. So they all correspond to this one source element, but you have multiple types dealing with this. And sometimes you need to use this, sometimes not. But it is there in the API, so you can actually talk about generics in a sort of, if it makes sense to you to do that. And then there's the util package that gives you utilities to reason about your source code. For example, code to figure out if you override or hide the method is in element utils. And there are tools to help you with types in the types class. And we've also included a lot of visitors. For example, there's a type visitor that you can just extend in order to easily do things with types. And yes, as I said previously, the way to sort of start using this today is by plugging into this from annotation processing. And this only runs today in source time. So here's an example. At one point in time, I needed to find out the size for unique parameter names in the entire JDK. And this was sort of the perfect tool for that job. If I want to look at all the parameters in a given source file, I just override element scanner 8, which is provided to you by the API. So I just override visit variable, and that will get called both for parameters and possibly something more. So I override visit variable, and that gets called on every variable, and then I just do a query. Is this a parameter? If so, take the parameter name, store it in my case, I used a map or something like that. Store it in a map with the class file name and go on, basically. And then I just ran this using the annotation processing plugin on the entire JDK source base. It was actually really easy. And other examples I've used this for. This is kind of my favorite API actually. I think I have like 10 or 15 visitors on my computer at work for doing sort of language querying features. I used it for, as I mentioned, parameter names. I wanted to do an index of all interfaces implemented by all classes. I think I even wanted the transitive closure of all interfaces implemented by all classes. And you can perhaps use your IDE for this, but since I work on the JDK source base, it is not trivial to fit all that into your IDE, because we have a lot of there are a lot of we pull in source from a lot of places. So I just hacked into the compiler to the make script and ran my visitor and got the sort of the data I needed. I think I also done calculations, or I have done calculations on average arity of declared methods in the JDK, for example, and those have been stuff that I needed to do for my work. So the observation here is that there is a need to do annotation processing at runtime. For example, with transactions. Your EE container, or when you compile your EE beans, they might not be fully aware of your container, so you might have to delay parts of the transaction code, for example. And what I claim is the better tool to do this is only available at source time, and so of course we want to change that. And here's a bunch of the pain points I've had working with reflection, trying to work on Java source. To start with, there is only arrays, no lists. So every time I want to print something, I have to do list. Is it as list or and then to get a list that actually has a sort of a useful printed output instead of the array that just prints the address in the VM. Other problems with reflection when looking at code is generics are sort of bolted on. And of course, generics were added later in Java, so I assume it wasn't trivial to sort of unify the reflection API, but still. So if you don't want to deal with generics, well, then you do get return type. If you do want to deal with generics, well, then you do get generic return type. And as a user, that is somewhat painful. I don't want to make that distinction at that point in time. And there's also a lot of irregularities in reflection. For example, you have get component type. It's available on all class objects, although it's only meaningful for arrays. And if you want to navigate, this source structure, if you are looking at the method, you do get enclosing. You have to navigating your way is sort of, you have to know where you are in order to know how to navigate. There's no easy way to navigate the source, the declared source structure, without knowing where you are. So, the Javax.lang model at runtime. And again, this is something we're currently working on. So what we have is we give you a factory to get Javax.lang model instances from reflective objects. It's currently named Core Reflection Factory. So I have two examples here. I get a type element from a class, and also I get an executable element from a method. And this is all I need to do to sort of jump into the model world. And hopefully, our intention is to make this as close as possible to the source Javax.lang model, so that most of your, hopefully all, but most of your code will work equally well on the runtime model and on the source model. But we do not yet have sort of hooks into annotation processing and tools, and I am not sure if we are going to do that or not. So here's an example. Right. Here I just want to print all the members of. I want to print a class basically of annotated element. So I create a mirror, an element mirror from the Java.lang reflects annotated element class, and I choose that because it's sort of, it only has four declared methods, so the output wouldn't be too long. And then I get this elements utility, and using this elements utility, I just print the entire annotated element. Perhaps I should have chosen an example that don't have element in the class name. And this is the output. And this is running purely at runtime. So this is the output from the example. And you can see, I noticed when I did this that it's probably not finished yet, because if you look at the line for get annotation, it says class, Java.lang class, and then Java.lang class, which isn't looking like valid Java to me. So I've probably done a bug here or there in this code. The next example is the overrides example that I showed you previously. You have these declarations: class A with a method M, interface B with a method M, and class C that extends A and implements B. And if you want to query does M override M, this is how you would do it in the model. First, you get an executable element for a.m. This is line 1, or where the comment says 1. And then you get the executable element for the interface method that you want to see if you override, b.m. And then you get the two type elements. On line 3, you get the class A, the type element for class A. and then you get a type element for class C. So, and then when you do this query, for example at line 4, if A.m overrides B.m, first you put on your I am class A hat, and then clearly it does not. And on line 5, we do it saying, hey, I'm actually class C. Does the declared method A.m override B.m? And it turns out, luckily, this is working. So A.m overrides B.m, that is false. But as a mem, when you look at it from the perspective of C, A.m actually overrides B.m. So this would have been a horror to write using reflection. And our hope here is that you will find this useful doing source exploration or whatever. One thing that showed up this Monday was someone asked if they could get annotations that did inheritance not only on classes but in other cases. So perhaps annotations on methods could inherit. And the answer is probably not, but given a suitable API that you can use to reason about source, you can do this yourself. And this is one of the sort of ideas we have with this, that this will hopefully be useful to you if you want to experiment with interesting annotation semantics, unusual annotation semantics. So, Javax.lang.model backed by core reflection. It's my favorite API. We think it's a great API to talk about Java source at a much more suitable abstraction level. We are working to make it available at runtime, and you have to stay tuned for more details. All right, that's my last slide. Any questions? Yep. Sorry, I can't hear you. Can you get closer or?
Sorry. You show us an API to query the class path to retrieve at runtime the executable elements with an annotation. I saw that there is some term the Oracle package you import. So will it be a standard API in the JDK or still?
That is one of the things so the question was, my first example had a package that said com Oracle model, where this is currently living. And the question was, where will this end up? And the answer is, we don't know yet. Hopefully it will be not only I'm certain it won't only be in the Oracle VM. Whether or not it will be a Java API or an API in OpenJDK, or that is, but the intent is that this should be available for all users of Java. That's. Thank you. Yeah.
Repeating annotations. We still have to make our container interface. We still have to do was it at contained or contained by?
Contained by and contained for.
Have you considered trying to make the containers anonymous? So that if you just put, let's say, contained on the individual, on schedule, on whatever, and then automatically, because you've only taken away some of the templated code, right? We've got to create the interface right now with what you demoed.
Yeah. So the question here was, couldn't we just skip declaring the container? So say this is repeatable, and then Javac would make the container for you. And yes, we have considered that, and it's very doable in sort of in a technical perspective. But we wanted to preserve the previous usage of the container is very important for a lot of EE software. So there's a lot of software that have manual containers, and we don't want to go in there and sort of obsolete that or make it difficult to them. So this feature has to take into account the previous usage of the container feature.
And it seemed like you were taking that into account with some of the new methods, because you're at runtime saying, okay, do I have a container explicitly declared, and I'm going to return the container, otherwise I'm going to return the repeaters natively, just, and so it looked like you're already doing that in the methods that sort of tricked it there. So that's why I thought that maybe you can't be anonymous.
Right.
Yeah.
So we did consider, or at least I did consider this for a while, but we choose not to do this in order to be sort of more backward compatible. Yeah?
So along the same lines, is there a reason against allowing both? So the backwards compatible form where you simply annotate your existing containers, or a repeated or repeatable annotation that creates a synthetic container.
Let me turn that around and ask, is it that horrible to have to do two annotations?
No, of course not. Is it that horrible to have to write a container annotation and use the container annotation?
Right. So I guess there's no technical reason why we can't do it, but I'm not sure it's a good idea. I mean, I'm not. So there are.
Although I guess there's nothing to prevent a third party from creating a repeatable annotation which generates the container class through annotation processing.
Right. No, that would be possible. You can just with annotation processing do your own annotation called synthesized container that you would annotate the same declaration with or something like that.
I mean, from my standpoint, I didn't see a huge advantage over taking away that container if I still have to do the templated code elsewhere. I still have to make the interface, I still have to add new annotations. You've added complexity to some of the get annotations, get declared annotations, things like that. So, to me, the jump from, well, I have to do everything except define declare the container, like on your JDK example, doesn't seem to be that big of a benefit if I still have to do these other steps. So that's
right. So the
From a provider standpoint instead of a client standpoint.
yeah.
But the provider, there's only one provider, there are many users. So the number of uses of repeating annotations or the number of declarations of it. So sure, it must have been it was not a undue burden to keep the existing idiom he has been using for how long it's been, and to allow that to transition to the repeatable form without having to variants to the repeatable form. So yeah, if we were allowing repeating annotations back to 2004, and we wanted to dispersion this and instead having an anonymous container synthesized with users. But given the history of this pattern being used for so many years, and we don't want to say to our new colleagues, well, before JDK 8, you have to have a container, and now afterwards, to use repeating annotations, you have to do something else, and you have to rewrite all the things that were meant to be repeatable in some other form, beginning without appealing. We just want to have one way to do this, have container recognized by the provider.
So from my perspective, I want to make it easier for the annotation user. I want to make it as easy and cleanly looking as possible when you're actually using the annotations. That's my main perspective.
When JSR 175 was being developed, somewhat later, the idea would be, or the feedback that
Yep.
What happens to generic when you move this model to runtime? How would that be? Would that be somewhat
So it turns.
limited?
Turns out there's a surprising amount of generics information in the class files. You just have to pick it out from, say, a field signature. There's or a method signature. So you can actually, although if you look at an object on the heap, it doesn't know it's a list of foos. But if you look at there are sort of a middle viewpoint where you declare a class, and from that class you can actually infer that a return type is a list of foos. So you can work around that to a certain extent, and I think that one of the problems, the bug that I mentioned with the where I outputted the annotated element. That is due to me misparsing the generic information in the class file. There's a type parameter there, and I think I just forgot to parse that, for example. So it turns out you can work around this, but there are, to a certain extent, there are limitations. Hopefully, they won't be. You can go a surprisingly long way without hitting them. Okay, thank you for coming.